I was telling one of my other classes the other day a story about when I was in college, and I don't know why, but I was just unlucky, and I always ended up with 8 o'clock classes, or when we were here, I don't know if they still have these or not, but on Tuesday, Thursday, they had 7:40 classes. And so I don't know if we have 7:40 classes anymore. Hopefully not. Do we? Do you know?
There's some labs.
There's some labs. Okay. But yeah, would have like Tuesday, Thursday, 7:40 courses. And every semester I either had one or the other. Like of my entire college career, I either had an 8 o'clock or a 7:40. And so my senior year, I had planned out my schedule, and I was just like so thrilled because like I had planned out my schedule. So my first class of every day didn't start until at least 11. And so I was like, I'm some sort of a genius, like this is just the greatest thing ever. And then like halfway through the summer, I get this letter in the mail, and it says one of the students in this certain math class couldn't make it at that time. So we decided to reschedule that class for 7:40 on Tuesday, Thursday. And I almost like openly wept right there, like by the mailbox, but we did it. And we had that class at 7:40 on Tuesday, Thursday. So I look around everybody's faces, and it looks like it's 8 o'clock in the morning, but that's okay. I forgive you. I understand. So anyway, let's get started. Like I said, if you haven't thought about that riddle, it really is that worth thinking about. If you haven't solved it yet, but if you solve it and you think you've got an answer, you can come talk to me sometime in my office, and I would be happy to tell you if you have solved the riddle. So let's talk a little bit about limits at infinity. So hopefully you got a chance to work through some of those problems and you have some questions for me. Any questions that I can answer? Yeah.
What would you say is the hardest question in the hardest problem in the homework?
I don't know. That's a good question. I don't know if I would say that one of them is necessarily the hardest, and I haven't looked at them really carefully recently, so I'm not sure. Maybe we'll find it.
So just on the first problem there, when it gives you vertical asymptotes and it's asking the limit as x approaches whatever number from the negative side, you can't just put that asymptote as the limit, correct?
So which one, for example?
So say for example 8a, limit as x approaches 2 from the negative side of g of x, you wouldn't just put 2 as the limit there.
Just a second. So 8a, I think I'm on there. Yeah, so you've got x goes to 2 from the left. Yeah, so the answer would be positive infinity. Is that what you said?
Okay, yeah. So I was just making sure that you don't just put that x is equal to 2, because that's...
No, yeah, you don't put x is equal to 2. You're kind of saying, like when you ask what is the limit of something, okay, you're basically saying it's a y value.
Okay.
Right? So in that case, the y value is really big. So yeah, positive infinity on that one. Yes, sir. 29. Yeah. Okay. So 29. We have the limit is x goes to 2 from the right. The limit is x goes to 2 from the right of 1 over the square root of x times x minus 2. Okay, and what we see, of course, is part A, right? So what we see here is x is going to 2. If I plug in 2, I get division by 0, right? And there's nothing on the top to cancel it out, right? So right off the bat, I know I'm dealing with like an infinite limit because I know that there's nothing on top to cancel out this x minus 2 factor that I have on the bottom. So I know that positive or negative infinity is the answer. Now I just have to figure out, well, which is it? So I'm going to take something just a little bit bigger than 2 and plug it in for x. And if I take something a little bigger than 2 and plug it in for x here, obviously this is positive. And something a little bigger than 2 minus 2 is also positive. So everything on the bottom will be positive, correct? And so I know that this must be going to positive infinity. Okay, because I know that the only options for the answer are plus or minus infinity in this case. So I just have to figure out which one is it. So just take something a little bit bigger than 2, plug it in. Part B, 29. Yeah, so now we're taking from the left. So part B, we've got the limit. X goes to 2 from the left of 1 over square root x times x minus 2. And so now we say, okay, what if we took something just a little bit smaller than 2? If we take something just a little bit smaller than 2, this guy is still going to be positive, correct? But this one, if I take something a little smaller than 2 and subtract 2, I get something negative. Well, this is sort of interesting, actually, because of this square root. Okay, and why is that? It's kind of like, well, this thing right here, it really needs to exist, right? If I'm going to say that this is negative infinity or something, and you might be tempted to, well, these values in here have to actually exist. Let's just even take something else, like take the number 1. If I plugged in 1, what would I get? Well, this would be 1, this would be negative 1, so I get 1 over the square root of negative 1. That's not so good, right? That doesn't exist at all. At least it's not a real number, right? So in the case that we're going for 2 from the left, this limit doesn't exist because it doesn't give me positive numbers or negative numbers. It's giving me like imaginary numbers. So I could say, I don't know if I should say it equals does not exist. I'll just say it does not exist. Does that make sense? And then finally, does it just ask what's the limit? Yeah, so since one side of the limit doesn't exist, we can't have a limit per se. So we would also say that the limit, part C, is x goes to 2 of 1 over square root of x times x minus 2. That also does not exist.
So we wouldn't try to like rationalize the limit, or what it's trying to take a limit out of, right? So you would try to multiply both top and bottom by the rational.
Yeah, you could do that. Yeah, it just won't save you.
Okay.
Because even if you do that, if you multiply top and bottom by that square root, it would get a nice thing on the bottom, right? Because then on the bottom, you just have x times x minus 2.
Yeah.
But on top, you'd still have that square root.
Okay.
And you still are going to get that like imaginary number coming out. So it's no good even if you rationalize it, unfortunately. Yes?
Something that I don't understand about like the positive and negative infinity numbers. For B, why can't you just use negative 1 for x? I mean, it is smaller than 2.
Why can't you just use negative 1? Well, you have to be a little bit careful, okay? So you said, why can't you just use like 1?
Negative 1.
Negative 1? Well, here's why in some sense. So if I'm using something just slightly, let's say, smaller than 2, okay, so like 1.9 is something slightly smaller than 2. That's sort of okay if I keep in my mind, this is really, really close to 2. If I go too far, like especially if I go past 0, like 0 is another place where there's like a problem spot. So if I go even further and go like out to -1, it might actually just give me different results. So like up here, if I used -1, this would be negative. This would, let's see, in this case, let's see. Yeah, I'd get -1, negative. It sort of would come out okay in this case, but in general, it's not going to be so good. But if I use like 1, then I'd get a positive and a negative, and then it doesn't exist. So this maybe isn't like the perfect example, but you shouldn't use a number that's very far away from the number you're going to. You want it to be like really, really close. 0.1 is just kind of what I use in my head, but I don't even plug that in. I just remember it's close. So don't go far away, like 3 away or something. It could actually change the result. Yeah, so you do have to be a little bit careful about that. Other questions? Yeah, go ahead. 23? Okay. Okay. So 23, we have the limit as x goes to 4 from the right of x minus 5 divided by x minus 4 squared. Okay. This again is part A. And again, we can see we're in that exact same situation where if I tried to plug in the 4, I get a 0 on the bottom because I have an x minus 4. And there's no x minus 4 on the top to cancel out that x minus 4. So that means we are in an infinite limit situation. And this is really easy when you're in the infinite limit section of the book, right? You're like, oh, they're all like this. When this kind of can trip you up is when you're not, and you just come up against a limit like this, and you don't recognize really quick that, oh, this isn't one I can factor. I need to actually, the answer is plus or minus infinity. So then I just have to figure out which one it is. So this is good to keep in mind for later, like on your exam and stuff, is like if you see a limit and there's not an x minus 4 on top to cancel out the problem spot, then it's plus or minus infinity. Okay, so the question is, which one is it? So take something just slightly bigger than 4. Well, something slightly bigger than 4 minus 4 is positive. Squared, of course, is positive. And something slightly bigger than 4 minus 5. So sometimes I'll do like a little squiggly line and just say, so the top is negative and the bottom is positive. So a negative divided by a positive is negative. And so I can say that this is equal to negative infinity. Okay, and now let's do part B, which is the limit as x goes to 4 from the left of x minus 5 over x minus 4 quantity squared. And that would equal, well, this time I'm coming just slightly smaller than 4, but it's not going to matter very much, right? Because the bottom is squared. So something just slightly smaller than 4 minus 4 is a little bit negative, but squared, it's positive. So the bottom is positive. And on top, something a little bit smaller than 4 minus 5 is negative. And so we see that it is negative infinity. And then finally, C, we probably just want the limit as x goes to 4 of x minus 5 over x minus 4 squared. And now we can just look at these two and say, are they the same thing? And in this case, they are. So I can say that this is minus infinity. That's it. Yeah.
Could you go over 31 and 55?
31 and 55? Sure. Okay, 31. So 31 is the limit as x goes to 0. Of x minus 3 divided by x to the 4th minus 9x squared. X to the 4th minus 9x squared. All right, so this one, the bottom is not factored out fully, so we could start by just cleaning up the bottom of that fraction. So let's write this as limit as x goes to 0 of x minus 3. We could factor out an x squared in this case. So we could have an x squared, and then what would be left over is x squared minus 9, correct? And we could even factor it further if we wanted to, right? Because x squared minus 9 is the difference of squares. So we could write this as the limit, x going to 0 of x minus 3 divided by x squared times x minus 3 times x plus 3. Okay. So the question is, what's happening as x gets close to 0? Well, already the question is it the same from the left and the right? Maybe. Let's just take it a little, something just a little bit bigger than 0 and see what happens here. By the way, can I just cancel the x minus 3's? It's a good question, right? And it makes us nervous because I think I said before that maybe we couldn't. Now, when you're taking a limit specifically, what are the points that you're really concerned about when you're taking the limit? What do you care about the most? Yeah, the points next to 0 in this case, right? So you care a lot about the points next to 0. You're not far away from 0. And even though it doesn't seem like 3 is very far away from 0, it's actually like infinitely far away from 0 in some sense. So it's kind of like, yeah, we're not dealing with x equals 3 here. We're dealing with x's are very close to 0. So we can kind of assume that my x value isn't 3. And in that case, I could, in fact, cancel the x minus 3's and write this as the limit as x goes to 0 of 1 over x squared times x plus 3. So it is okay to cancel those in this case because I know I'm not so concerned with x being 3 in this limit. Okay. So now what about if x is going to 0? If we had something just a little bit bigger than 0, and I squared it, it's positive. And if I added 3 to it, it's positive. What if it were a little less than 0? If I square it, it's positive. And if I add 3 to it, it's positive. So it doesn't matter if it's less than 0 or greater than 0, I'm still getting positive infinity. So that's my answer. Sound good? Okay, so you said 3155? Okay. 50, oh, I didn't, let's see. 31, oh, I guess I kind of did it. 31, did I do the wrong?
something?
No, so 31's got three different.
Oh.
Same equation, three different limits.
Oh, because now they're going to 3.
No.
Oh, I see.
So in that sense, could we cancel those threes?
In the case where you're going to 3?
Going to three.
Yes.
Okay.
Because also there, you don't care about what's happening at 3. You care what's happening around 3.
Yeah.
So it's not 3 itself. And that's kind of the key and lets you cancel. Should I do the other 2 parts of 31?
Yeah.
Okay. Yeah, no problem. Okay, so this was part A. Let's look at part B. So part B, we have the limit as x goes to 3 of x minus 3 divided by x to the 4th minus 9x squared. Okay, so very similar. We can do the same factorization that we did before. So I could rewrite this as the limit as x goes to 3 of x minus 3 on top. On the bottom, I have x squared times x minus 3 times x plus 3. And then the question was, well, what about in this case if I'm going to 3? Can I still cancel the x minus 3's? And the answer is yes, we can, because when we're going to 3, we're not at 3. We're around 3. So everything's fine. And we can cancel the x minus 3's. So I get limit as x goes to 3 of 1 over x squared times x plus 3. And am I going from like the right or left?
This is just going to 3.
Okay, just to 3. Very good. Okay, and so what do we get here? If I take something, at this point, now this is kind of interesting.
This 3 works, doesn't it?
Yeah, 3 actually works because what was the bad thing on the bottom when it comes to 3?
Dividing by 0.
Yeah, dividing by 0, but what term caused division by 0? X minus 3, but I canceled it out. That means it was just a whole. It isn't going to infinity, right? So it just has an answer. And now at this point, I could just plug in 3 and get the answer, which is just kind of a normal problem that we've been doing for the last couple days. And so if I plug in 3, I get 1 over 9 times 6, correct? Which of course is 1 over 54. Okay, and so now maybe they go to negative 3.
Yeah.
Yeah, that makes sense.
And that's where we get negative plus.
So this one, part C, same limit, except x is going to minus 3 of x minus 3 divided by x to the 4th minus 9x squared, which of course is limit as x goes to minus 3, x minus 3 divided by x squared times x minus 3 times x plus 3. And now the problem spot is the x plus 3. And there is no x plus 3 on top to cancel it. So I can say right off the bat, okay, it's plus or minus infinity. I just have to figure out which one it is. Can I cancel the x minus 3's? I can, because I'm nowhere near 3 here. So this is limit as x goes to minus 3 of 1 over x squared times x plus 3. So now I need to see, okay, what about from the right and from the left a little bit? So if I take something just a little bit bigger than negative 3, like negative 2.9, and I plug it in, this obviously is positive because I'm squaring it. What about this one? Still positive, so it's positive infinity. What if I took something slightly less than -3, like -3.1? This is obviously positive, it always is. -3.1 plus 3 is negative. So on one side it's negative, on one side it's positive. So on one side it's going to negative infinity, other side it's going up to positive infinity. So what do I say about this limit?
Doesn't exist.
Yeah, that one doesn't exist.
Can we also assume that it'd be a vertical asymptote at -3?
Yeah, there certainly would be a vertical asymptote at -3. I don't know if they ask for that or not, but I don't think so. No. But yes, there would be a vertical asymptote at -3. It just would go up on one side and down on the other side. So there isn't an official limit there. Sound good? So that's 31. And I think you also said 55. Is that right, 55? Okay. All right. So 55. We have finding a rational function. So find a rational function of r of x such that r of 1 is undefined. Limit as x goes to 1 of r of x is equal to 0. And the limit as x goes to 2 of r of x is infinity. So we kind of need to make up such a function. So r of 1 is undefined. The funny thing is, does it tell us that we actually have to come up with, let's see, find a rational function. Oh yeah, a rational function. All right, very good. So we need this limit to be 0 at 1. And we need, okay. So if this is true, then the chances are that on the bottom, I'm just making stuff up right now, by the way, so we'll see how it goes. What, if I'm going to 2, what would be the bad thing that should show up on the bottom? Like that would kind of give me possibly an infinite limit. What is it? What's the factor that would come up down here that would be bad if x were going to 2?
X minus 2.
Yeah, x minus 2. Everybody agree? But I also know it does go to infinity. So I'm going to say x minus 2. But if it's going to 2 from the right, this thing's positive. If it's coming from the left, this thing's negative. I'd like it to always be positive. So what I'm going to do is I'm just going to square it, just to make sure it comes out positive, always. Okay, so now, right now, what I've done is I've kind of created this situation where if it's going to 2, it's always going to, there's no x minus 2 on top right now, so this thing's going to shoot up to positive infinity. Okay? What about this guy? We need, as we go to 1, we want this thing to be 0.
X minus 1 on top.
Yeah, so if I put an x minus 1 on the top, then as I go to 1, this would in fact be 0. In fact, the functional value is even 0.
So then we also have to have a.
But you want r of 1 to be undefined. So how do we do that?
Making a whole.
How about we put a x minus 1? Let's see, is this going to work? It may not. Because right now, I don't think it goes to 0.
If you square the x minus 1 as well.
Yeah, that might work. So if I say squared here, this probably will get the job done. Okay, so let's think about it for a second. What is r of 1 in this case? So if I plugged in 1, it's undefined, right? Because I get division by 0. What is the limit as we go to 1 of this function? Well, one of these x minus 1s would cancel. And then when I plug in 1, I just get 0 on top. And it would be 0. Correct? So this one checks off. And then this one is the only one that I still need to wonder about. And that is, well, what happens? Did adding this other stuff mess me up? Well, the top is always positive. Agreed? No matter what I plug in. So if I plug in something a little bit bigger than 2 or a little bit less than 2, the top's always positive. So what happens to the bottom? Well, this thing's always positive also. What about this? If it's a little bit bigger than 2, 2 minus 1 is 2.1 minus 1 is positive. 1.9 minus 1 is positive. So the bottom's always positive. So it's going to be positive. So this guy would get the job done. It's not the only one. We could do something else and probably get the exact same thing, but this would get the job done. Any questions on this one? This one it's a little bit tricky. Yeah. Yeah, why does the limit as x goes to 1 of r of x equal 0? Yeah, okay, so if I was taking the limit of this thing, let me maybe move over here for a second. So let's say we're taking the limit as x goes to 1 of the function that I made up, x minus 1 squared over x minus 2 squared times x minus 1, okay? If I were actually going to take this limit, the first thing that I would see is I could cancel one of the x minus 1s, right? So an x minus 1 and the square could cancel, and I'd just be left with the limit as x goes to 1 of x minus 1 over x minus 2 squared, right? And now what I'd see is, well, what happens if I just plug in the 1? If I just plug in the 1 here, the top is 0, and the bottom is minus 1 squared, or just 1, right? And so we just get 0 over 1, but that's just 0. And that's what we wanted it to be. Does that make sense? Yeah. Other questions? Let's see, somebody is writing something on. Yeah. We did 31. Somebody asked for maybe 45. Okay. So 45. We are asking for the location of vertical asymptotes. So look at the following limits and find the vertical asymptotes. Okay, so let's look at f of x is equal to x minus 5 divided by x squared minus 25.
We break that equation down right off the bat.
Yes, I would just factor the bottom right off the bat. So we could also write that f of x is equal to x minus 5 over x minus 5 times x plus 5. Now, This is where you can't just go cancel. There's no limit, right? So I can't just say that this is just 1 over x plus 5. That's no good. But what I can say is I can say, okay, where are potential vertical asymptotes? Potential, not necessarily that they're actually there. Well, anywhere where I get division by 0. So any x value that would give me division by 0 potentially could be a vertical asymptote. And then I just have to ask the question, like, for x minus 5, is there an x minus 5 on top to cancel it? There is, and so it's not a vertical asymptote. It's a hole in the graph. With the x plus 5, I say, is there an x plus 5 on top to cancel it? No. So this one does give me a vertical asymptote. So this would have, so f of x has a vertical asymptote of, let's see, I guess it would be x equals -5. That's not exactly what the question asks, I don't think. It's going to help us get the answer, though. So basically it says analyze the following and find the vertical asymptote. So they just say find the limit as x goes to 5. But if x was going to 5, then we could cancel these and I'd just get like 1/10. Right, so for the first one, let me write it down. If we were finding the limit as x goes to 5 of x minus 5 over x minus 5 times x plus 5, now canceling the x minus 5s is okay. So I cancel the x minus 5s and I get the limit as x goes to 5 of 1 over x plus 5, which is just 1 over 10.
So now that we took the full limit, when it asks for from the left side and right side, we can just assume those are 1/10 as well, right?
At 5?
At 5, yeah.
At 5, yes, it's 1/10 from the left and from the right. If you can just plug it in, then it doesn't really matter if it's from the left or from the right. Does that make sense?
Yeah.
So anytime that you can just plug it in and get an answer, the right one, the left one, it's all wonderful. Okay, let's see. The second part of that was, what about from if you're going to -5 from the left? Okay, so what if you were taking the limit as x goes to -5 from the left of x minus 5 over x minus 5 times x plus 5? Well, again, if you wanted to, you actually could cancel the x minus 5s at this point and just write this as the limit as x goes to -5 from the left of 1 over x plus 5. And now we're going to -5, slightly smaller than -5, so maybe -5.1. You add 5, and that would make the bottom negative. So this would end up being -infinity. Similarly, so this was part B. Part C probably asks for the limit as x goes to -5 from the right of x minus 5 over x minus 5 times x plus 5, which is the limit as x goes to -5 from the right of 1 over x plus 5. And now we're taking something just a little bit bigger than -5, like -4.9. We add 5, that gives me something positive on the bottom. So I get 1 over a positive, which is positive infinity. So there is a vertical asymptote at x equals -5, but there's no limit as x goes to -5. It goes to positive infinity on one side, negative infinity on the other side. So there's no limit there, but there is a vertical asymptote. Sound good? Let's see. Somebody asked about 54. And 54 is the one where you're doing matching. I think that sometimes when you do these matching problems, the easiest thing is to kind of look at like, okay, what's all the bad stuff, or what can I determine just by looking at these functions? So if I'm looking at 54 and I just look at like part little a, so what could I possibly plug in? Let me write this down just in case not everybody has their book right in front of them. So the first one is little a. It says f of x is x over x squared plus 1, right? And what I'd say is, okay, what could I possibly plug in for x here to make the bottom 0? Would that even do it?
I factored out the x plus 1. Oh, you can't do that, it's not difference, never mind.
Yeah, because so if x squared, in other words, x squared would have to be -1.
Yep.
That's not happening, right? So what I know right off the bat is there are no asymptotes because there's nowhere where the bottom is equal to 0. So I look through and I say, are there any of these graphs that don't have any asymptotes? And it's D, right? So capital D has to be this one because this one doesn't have any asymptotes at all. Okay, so that's a lot easier than trying to kind of say, well, what does it look like? And what I do know is it doesn't have asymptotes. So this has to be capital D. Okay. Let's look at maybe B. Let's look at f of x is equal to x over x squared minus 1, which could also be written as x over x minus 1 times x plus 1. Where could this thing be 0 on the bottom?
1.8.
Yeah, it could be at 1 or at -1. The question is there anything, are these holes or are these vertical asymptotes? So is there something on top to cancel this x minus 1 or this x plus 1 out? Or are they both going to be vertical asymptotes? They're both vertical asymptotes, right? So you need to look for a graph that has 2 vertical asymptotes, one at -1 and one at +1. And if I look on here, it looks like there are 2 of those, correct? So C and F both are candidates at this point. And then what I'd say is like, well, but I know that one of those, f of 0 is 0. And in this case, what is f of 0? If I just plug in 0 to this thing, I get 0, correct? So that means it must be C.
So because you're dividing 0 by 0?
No, just because what I'm doing is I'm saying, what is f of 0? If I plug in 0, what do I get out of this function?
Yeah.
And I just get 0 divided by 0 minus 1, which is just 0. And so I know that the one where f of 0 is 0 is the one that I want. And C, f of 0 is 0. F of 0 looks like it's -1. Okay. Yeah, and then I just keep going using this same sort of thinking. It's like, maybe I'll do one more just to be clear. So C, we have f of x is equal to 1 over x squared minus 1. 1 over x squared minus 1, otherwise known as 1 over x minus 1 times x plus 1. What can you tell me about the vertical asymptotes of this function? Yeah, -1 and 1 has a vertical asymptote. So really we don't have many options left, right? We already said one was C, so the only other one with 2 vertical asymptotes was F. And if we really just wanted to make sure, we could plug in 0 and see what we get. If we plugged in 0 for this, we'd get 1 over -1, which is -1, which is perfect. And so we get this one must be F. And then just keep using the same logic, right? Figure out where are the vertical asymptotes, which graphs have those kinds of vertical asymptotes, and then which one is it? Maybe use some other piece of information like F of something to figure it out. Sound good? Any other questions? Okay, just for some feedback, how is it going watching the online lectures? So far, so good? Any questions, comments, concerns? Everybody's good?
The audio on some of your videos, a little bad.
Yeah, like the very first one. Yeah, the first one, there's something, yeah, I need to like replace that video. But I think that the rest of them are a lot better than that one. Yeah, that first one, I totally agree. I don't know what happened on that, but I think everything else should be way better than that. Yeah. Did you have a comment too?
Just when it comes to the tests, will we probably review things?
Yes. Yeah, we will. So, and the test is even going to come up relatively soon. And so, yeah, we will have a review day. Do you remember on the syllabus what day it says? What, the 10th? Yeah, so, and is that a Wednesday? I think so. So what I usually do is like the Monday before, we'll just have a review day and talk about what have we talked to up to this point. And then Wednesday and Friday actually will be the exam because we can't all be in this room at one time. So 2 of the groups will come on Wednesday, 1 of the groups will come on Friday. Yeah. So not this coming Monday, but a week from Monday will be review day. Yeah, good question. Anything else? All right. Well, have a wonderful weekend, and I will see you on Monday. Go ahead. There is a new lecture for you to watch, new assignment posted. Yeah, have a good day.
Thank you.
You're welcome.